This video is designed to introduce the method of correlational studies. So we're doing this as part of our non-experimental methods of research. And as you can see from the specification, the bit I've highlighted in yellow, there's lots of different aspects of correlational studies we need to understand, both from how it's used as a method in research and how it's administered as a technique, but also the statistical part of it. We'll see very shortly that it's a mathematical technique used in research, and therefore we need to be able to understand it as a statistical tool. We need to interpret the information that correlational studies produce as well, and understand the statistic that comes from correlations in form of correlation coefficients. So hopefully this video will be of help with it. Okay, so our definition of a correlational study is a mathematical technique. So it's just working on statistics that are derived from either the participants or the situation that we are studying. We are going to, in this method, measure two different variables, and they are referred to as the covariables. So just to flag up that sometimes students get these confused. They're used to two variables in experiments being the IV and the DV, but we're not going to refer to them as here because it's not an experiment. So they are referred to as covariables. So within a correlational study, we would measure both of those and we'd see whether they are linked. See whether if one is high, the other one is also high, and when one is low, it's also low, or whether they seem to have an influence between each other that would infer that those two variables are linked. So for example, if we measured the stress levels of an individual and the number of days that they had off ill in a year, then we might be able to work out that there's some sort of link between stress and illness. Okay, the thing that you'll get used to seeing in relation to correlational studies are the way that the data is visually presented. This is known as either a scatter diagram or a scatter graph, and you can see some examples of some scatter graphs on this slide. Our scatter graph is going to give us two pieces of information. It's going to tell us the strength of a correlation, so how well linked the two statistics, the two covariables are, and the direction, whether they have a positive, negative, or no relationship at all. So once you're happy with this, we can move on to looking at those directions. So the types of correlation either form into three different categories. One can be a positive correlation. So when we're referring to positive correlation, it means that as one variable increases, the other does. And if you look across at the slide, you'll see that some of our scores down this end have a low score for both. So it means when they were scored for low for one covariable, the other covariable was also low. And then when we look at the other end of it, we've got when one covariable was high, the other one was high. So we can see that there is that relationship where one variable is causing a similar effect to the other variable. Now in a negative correlation, we're seeing the opposite happen. So where one score ends up being high, that's causing the other variable to score low, and vice versa. So when we score low for one variable, that causes a high score for the other, and it therefore causes this downward trend that we'd see as a negative correlation. When no correlation exists, we'll see a random pattern of the plot points here, and this just means that it doesn't matter if sometimes when the variable is high, the other one is low, sometimes when one variable is high, the other one is high. It's just a random association. There's absolutely no link between the two variables we're measuring. The other thing we can look at with correlational studies is the strength of correlation. Now, the strength of correlation can be assessed by how close the results are to the general trend, that diagonal line we've got. And what you can see on the image here is a range of different strengths of correlation. On the left-hand side, we've got perfect positive correlation. You'll notice that the plot points are in a complete straight line, and therefore we can say that they are perfectly related to each other, and they have that regular relationship, so they're always linked in the same way. As we move through the positive correlations, you can see how those plot points spread away from that centre line and become more scattered, indicating that the relationship isn't as strong, and we start to move towards what we describe as being a weaker positive correlation. Now, sometimes it's about the use of language here, so what I'd recommend is terms such as strong, moderate, weak are all good terms to use to describe that. In the middle here, we have no correlation, and as we start to move towards the negative end, we can see that they start to become closer and closer again to that negative trend line, and the closer they are to it, the more perfect the negative correlation is. So we have perfect to the end here, we have quite high strong correlation here, and we have weaker moderate correlation here. The numbers that you can see underneath each of these scatter graphs are the correlation coefficients. Correlation coefficients range from 1 to -1, with, as you can see, 1 indicating perfect positive correlation, -1 indicating perfect negative correlation, and 0 indicating no correlation at all, with any numbers in between showing us the degree at which that correlational strength exists.